I have a number of NAS devices that I use, including some Synology 12 bay, Terramaster 4 bay, and a Ugreen 6 bay, and all of these are good for a variety of tasks. Some are stronger in some areas than others, but whenever I look at a NAS device on the channel, people always, I think rightfully, compare this to just doing a self-build. And this is especially true if you don't plan to use the native OS, but in fact just plan to install something like TrueNAS, Proxmox or Unraid on these devices. So I thought, for fun, I would build a cheap TrueNAS server for one of the most common use cases that people really want a NAS for, and that is file and media storage and as a media player. And also take the chance to get deeper into TrueNAS and check out what is new in the most recent release. So if you do have old hardware lying around, then you can use this. But this can often lead to a bulky PC case that doesn't really give you real hot swap disk access and sometimes still needs you to buy components to get it fully running. So instead, I wanted to build something small and neat that uses minimal power, didn't require a full PC case crammed with disks, and so in this video, I'm building a TrueNAS server using one of the cheapest and lowest power mini PCs I could find, and then using a 6 bay, hot swap capable USB 3.2 Gen 2 DAS for the storage. And this creates a small, power efficient build that's low on noise, and other than a couple of minor aesthetic irritations, it looks pretty good also. And of course, you can get a 6 disc hot swap capable NAS with hardware transcoding in a media server for $400 to $500 plus your choice of disks, and one that uses around 50 watts of power draw and is small and functional. So let's start with the hardware that I chose for this. So first of all, I went for a mini PC with the Intel N150 chip on the Twin Lake architecture. And this is a relatively new 4-core mobile chip released in November 2024, and it supports both low power DDR5 and DDR5 memory. So this is an up-to-date offering from Intel, and the N150 is actually a real beast for its price, size and power consumption, with an on-board GPU that can support transcoding at 4K. The chipset also supports USB 3.2 Gen 2 for 10 gigabits per second per port, with a decent GPU for transcoding. It's also efficient with the CPU having a stated TDP of just 6 watts. So I'm going to be checking on the power usage in different scenarios during testing. Now I looked around to see what was available with this chip, and I in the end picked up a GMKTec G2 Plus nutbox device from Amazon UK for about £160, and this came with 12 gigs of LPDDR 4800 megatransfer RAM installed and a 512GB SATA SSD, and it's actually a similar price in Amazon US at $160. There may be some shenanigans with vouchers etc. to get that price. Now the SSD on this PC actually comes preloaded with Windows 11. But I swapped this out so I could use the Windows OS later, and I installed a 256GB Transcode SSD to install the NAS OS on. The box is physically tiny. It comes with two 1 gigabits per second Realtek NICs, which I know are not everyone's favourite, but it does also have two HDMI and a DisplayPort, and the three USB 3.2 interfaces. Interestingly, the specs would imply that the USB ports are Gen 1 5 gigabits per second ports, but we're going to come back to this later because it clearly appears to be 10 gig ports. There are options with 2.5 gigabits per second networking, but the 1 gigabits per second does what I need for this project. Now the device has just one SATA slot, so there's no option for NVMe, but again, for my purposes, this spec is fine. 16 gigabytes is the max if you want more RAM, but it is single channel, and of course ECC is not supported. We're going to come back to these specs and what it means for TrueNAS a bit later. Now, the onboard GPU is also pretty solid. It comes with 24 execution units and performs native decoding of modern codecs, including AV1, with resolutions of up to 4K at 60 frames per second with HDR support. It also supports Intel QuickSync for hardware offload support, and this gives you reduced power and heat generation during transcode or playback. And I plan to put this to use with Jellyfin as a media server. So it's a great package for a mini PC due to its size and power requirements, heat generation and solid performance, and it's great for more power efficient use cases. So what you can see here is that I'm building a budget NAS with all the base capabilities to perform file sharing, media playback and direct output. I am not building a NAS here for enterprise class performance and resilience or for support for large scale VM hosting. We will talk later in the video about the capabilities you get and the limitations, but most of the selection here is about baseline NAS features with low cost, size and power footprint. Now, what is clear is that a mini PC with a single onboard 256GB SATA drive isn't going to provide decent file storage on its own. So I'm pairing this with a 6-bay direct attached storage chassis. Now this unit was sent to me by Terramaster. It's well built with a nice solid industrial feel to it, and it's quiet with 2 fans to cool the disks. Now Terramaster do build some really nice NAS and DAS devices, and they do it at a decent price point, and I've used them for quite a while now. Now DAS devices are simple, but their job is to provide physical placement for drives, cooling, hot swap capability and connectivity. This DAS is the Terramaster D6-320 model, and it comes with 6 3.5-inch SATA bays to host either spinning disks, or you can host 2.5-inch SATA SSDs if you wish to. I've populated it with 6 Seagate Ironwall 4TB NAS disks, which come in typically between £85 and £100 or dollars. You can choose whichever drives are going to work for you, but I match these for performance at a decent price. Now the DAS supports 10 gigabits per second over USB-C, and it comes with a USB-C to USB-C and a 3.2 Gen 2 USB-A to USB-C cable in the box. It's nice to use with a NAS because it comes with 6 hot swap bays with LED indicators on the front for online activity. They also have an easy fit toolless mounting system, so replacing drives is easy. Now the DAS comes in at $300, and their affiliate links to all the hardware can be found below. Please check in also, as prices can vary and sometimes deals can be had there. So what we have here now is a 6-bay compact NAS, self-built but small and neat with low power draw and minimal build for around $460 plus your drive selection. And this is going to be competitive with pretty much any true self-build option, and will be smaller, neater, quieter and more power efficient than a build if you're going to use like second-hand server hardware. And we're going to be testing all the power consumption figures during the various tasks later. If you compare to a pre-built dedicated NAS, any 6-bay is likely to cost at least $100 to $200 more and may come with lower end CPU and less memory, so it's certainly an interesting option, and this hardware is great for experimenting with the likes of TrueNAS, Proxmox, Unraid, etc. for home lab use. Okay, so let's get to the actual setup and build. So first of all, I'm starting with TrueNAS Scale Community Edition on version 24.10, which is called Electric Eel. Now when I started this testing, this was actually the current stable release, but just a few weeks ago on April 15th or so, 25.4, also known as Fangtooth, went mainline. And I'm actually going to be upgrading that during the tests, and this is primarily to address some of the problems that I ran into. 8GB is the minimum spec with 16GB recommended, but my mini PC comes with 12, so we're going to see how this holds up. The 16GB mini PC option is maybe $30 more if you want to go there, and in fact a replacement DDR5 16GB SODIMM is only going to be about $40 anyway. I want to call out now that TrueNAS explicitly discourages USB storage, and this is primarily concerns about stability of the connectivity and the opportunity for unintentional disconnects. In this case, this device is not critical, and I want to test how it really performs in the longer term, and I'm going to report back on how that goes. So, to the install, there is going to be a lot of content here which I'm trying to move through briskly, so do feel free just to pause or rewatch sections if you need to, and I'm going to include sections in the video to help. After downloading the image from TrueNAS site, I create a bootable USB stick to install from, and I personally use Rufus for this, but Balena Etcher is another option which people seem to like. I have had problems in the past with creating TrueNAS bootables using an ISO, but if you create the disk with a DD image, it seems to work just fine, as you can see here. Now, check you are writing to the correct drive, as this operation will delete everything from the device, and you're going to have to click OK to confirm this. And next, having attached the PC to the DAS via a USB cable and installing the disks, we can now boot into the PC and interrupt to go into the BIOS by pressing the delete key. Now in the BIOS here, I didn't mess with any power settings, so it's basically default. I did change the colour of the PC LED to green, and this is just to match the light on the DAS, but you could disable it entirely if you prefer. I then set TrueNAS install USB to be the boot device, and after that, save and exit and reboot to get the install started. It's quick and easy. Now the install itself is straightforward and requires little input, other than choosing the device to install TrueNAS on. And in this case, this is the 256GB SATA drive. Now I took the default here and provided a password for the default TrueNAS admin user. I'm installing TrueNAS 24.10 at this point, known as Electric Eel. I'm going to install this, and then we're going to do an upgrade, and this gives me a chance to show you a couple of relevant improvements that happen going up to 25.4. The install itself takes about 2 minutes, and I've sped it up here, but at the end I picked up a dynamic DHCP IP address And it does in fact report the URL at the top of the screen here for you to connect to the web UI. Once set up, I would change this to a static address so it doesn't go changing later. And if you're not sure what DHCP address is, don't worry too much. Your home router is typically going to provide this, just like it would do to a computer or to a laptop. Once running, the power draw is around 10 watts for the mini PC and around 33 watts for the NAS with the 6 disks running, so it is light on power draw. So here we are, hardware set up, the TrueNAS is installed, all easy so far. So now let's get some basic config into TrueNAS. And this isn't an in-depth config guide, but I'm going to show you what you need to do to get NAS up and running network shares and getting a media server installed in, like I said, in this case, it's going to be Jellyfin. Now, first job, log in with the user account we set up earlier for TrueNAS admin, and we're going to set up some basics. I'm going to enable SSH for console access, which you may not need, but this is so I can show a few things during the config and testing. And then turn on SMB so we can share media and files over the network with other media players. So I personally use the NVIDIA Shield device for playing content over SMB shares on TVs. Next, I'm going to configure this to use redirect access to HTTPS, and this is really just to ensure that all access to the UI is encrypted, so your logins, etc. are not visible over the network. I'm not sure why I can't fully disable HTTP here, but at least a redirect will ensure that users are sent to a secure login page. So we will restart the web UI and you'll get this warning page, and this is just because I've not issued TrueNAS a properly signed certificate issued by a validated certificate authority. But if this is your TrueNAS on your network, then this is not the thing you need to really worry about. We log in again as TrueNAS admin, and now we're going to create a dedicated user that we will use instead of the default account. And I'm going to create a user called some tech guy. I'm going to add this user to the local admins for managing TrueNAS. And there are a few options I need, so I will do some things in the CLI, namely selecting a default CLI shell. I'm also going to allow all the sudo commands, and I'm going to allow them all with no password. As it's just me using this box, this allows me to run privileged commands in the shell without constantly re-entering and password to elevate my privileges. In an enterprise environment, you likely wouldn't do this, but this is just my home lab. And lastly, I'm checking the box here that this will be an SMB user. This allows me to access network shares using the account based on whatever permissions are applied to that network share. Now those permissions can be tighter than my permissions here, so just being an SMB user doesn't necessarily grant you full access to modify data on network shares, but we're going to come to that a bit later. Okay, now let's log out of the TrueNAS admin user, and we're going to continue our configuration with my SomeTechGuy account. Next, I'm going to adjust some widgets on the dashboard to move info about CPU, memory, usage, storage, etc. to the top. Of course, this is optional. And now let's get to the important stuff, setting up storage pools. And obviously, a network attached storage device isn't going to do much without adding some storage to attach to the network. So as I've said before, I've chosen 6 of the 4 TB IronWolf NAS disks for this. And just briefly, here's a performance chart of these disks from previous testing I've done, and we can see that they peak really at around 210 megabytes per second, and these are for large read operations, and these are really ideal conditions, and this also drops as you move across the disk surface. So basically, they are really nicely aligned from a performance perspective to a 10 gigabits per second USB 3.2 connection. That's going to provide a max theoretical throughput of around 1200 megabytes per second, around the same as the max throughput of all 6 of these disks. So that USB connection is not going to be the bottleneck, even for on-NAS operations like array rebuilds and scrubs, etc. Now similarly with the 1 gigabits per second network interface, and none of the I/O here is going to be the bottleneck for actually accessing data. And even if you had a 2.5 gigabits per second network at home, this wouldn't be either. In fact, you're going to need a 10 gigabits network to start to see the NAS disk I/O as a serious constraint. And again, it means that there really isn't a huge amount to gain from using SSD drives in the NAS unless you have that 10 gig network, other than maybe some reduced noise, but then you're going to come with increased cost and reduced capacity to go with it. So for this use case, spinning disks really are the way to go. Okay, I'm going to start by creating a new pool and giving it the name Pool 1, and of course you can call yours whatever you like. The pool then requires at least one vdev or virtual device to be added, which is in itself just a set of disks. So I'm going to configure this as a RAID Z2 setup, and this means it has 2 disks of redundancy and I will get the equivalent usable capacity of 4 disks. You can also choose a RAID Z1 setup, and for 6 disks this isn't unreasonable, but on arrays larger than 5 I tend to move to 2 disks of redundancy personally, and this is because if one disk does fail, replacing that disk and rebuilding the array can put a lot of stress on other disks, and it can lead to additional failures, right? So this gives you some wiggle room for another failure during the recovery. But of course, the usual caveat, if the data is important, back it up. No matter how redundant a disk array is, it is not a replacement for backups for many reasons. I'm not going to get into the detail on ZFS pools here in this video, but just consider that using the stripe option here leaves all your data at serious risk of loss if a disk fails. We can revisit more details on pools, vdevs and layout options another time, but here I'm using RAID Z2 and I'm choosing manual disk selection, creating a new vdev by clicking add in the top right and then dragging all my disks into that virtual device. Now there are lots of other options here that provide greater resilience and performance, but in this case I'm just setting up the basics, and the use of these options requires more compute and more storage hardware, and you won't get any benefit from it for the majority of smaller use cases. As I mentioned before, this NAS is for media playing and for lab work, and it's optimized for price and simplicity over high performance. Okay, we submit the config and the pool is created, and the file system initiator, we can see the devices in the pool here. So now the storage pool is created. We need a way to organize, store and share files, and for this we're going to create a dataset. So as an example, I'm going to create a location to store media. I'm going to create a user who can read this remotely to use on remote media players, and then I'm going to create a share for this user to actually access the media over the network. So let's start by selecting credentials on the left and then groups. Rather than granting access directly to the user, I'm going to create a group with access and then place the user in the group. And this approach makes it simpler to add additional access to later to other users. So the group is called read-only media and it's an SMB group. So the group can authenticate to a network share using the common server message block protocol, and this is typically used in places like Windows or Linux Samba. Once the group is created, then I create a user called media user and I select the group I just made as the primary group for this user. Now they don't need a login via SSH, so they don't need a shell, and they don't need a home directory on TrueNAS either, so these are all left blank, but they do need to be an SMB user and be able to authenticate to the SMB service. Let's save this. Okay, next, let's create the data store to store the media in, and then create that network share so the user can access it. In datasets, we select add dataset in the top right corner. I'm going to call it media, and I'm going to select it as an SMB type preset, and this way it'll create the needed SMB share automatically. Now on the left menu, we can now select shares, and we can see network shares here including SMB, NFS and iSCSI block storage targets. NFS and iSCSI are not running currently, but we do see our one SMB share here called media. I click on this little three-line icon here to edit the share ACLs or access control lists. Users will need both SMB permissions and file permissions, but by default our built-in users come with the file permissions, so the SMB access is really there just to allow them to access these files over the network. In this case, I'm going to give access to the read-only media group to have read-only permissions, and this will allow them to access, view and execute files on the share only. It won't allow creates, modifications or deletes of the files. I then add another permission for my some tech guy user, and this is so that I can use the file share, copy files onto it and manage it remotely. And this is it. And now I can copy media up to the share. So we're going to get Jellyfin installed as a media server, but first there is a bit of an interesting rabbit hole to take you down. So first of all, I mentioned that the specs on the mini PC earlier are that it supports USB-C 3.2 Gen 1 of up to 5 gigabits per second. And if I look here at the Amazon listing, I can see it here. But other info suggests that it really should support Gen 2 speeds of 10 gigabits per second, so let's go take a look. Now, irritatingly, TrueNAS has had such a dislike of USB storage that they didn't include basic tools such as LS USB in the OS, at least in the 2014 electric eel release or before. So it is possible to run a container and see what's going on here, and you can do this by spawning a privileged container and then running LS USB in the container. And I'm doing this using the Alpine distro, but this cut down OS only has the basic LS USB, so I'm going to start Alpine container, I'm going to attach to it, I'm then going to install the USB utils package, and then we can run ls-usb-t to get the devices in a tree view. And we see actually that the DAS is connected at 10 gigabits per second, as are all of its disks. And we can see here that the root hub actually appears capable of USB 3.2 Gen 2 x 2 speed of 20 gigs. However, with no USB-C ports, there's no way to connect to that speed, but access at 10 gigs is available. Now, the good news is that the pushback on LS-USB has ceased in 25.4 Fangtooth, and LS-USB is now included in the OS. And this is one reason to upgrade the OS. However, there is a more important one. If we look at the Linux kernel on version 24.10, it's kernel 6.6. Now, this doesn't include drivers for our Intel graphics card, so getting hardware encoding and decoding to work is going to be a problem. You can patch the kernel, but again, the kernel in the new Fangtooth release actually comes with the kernel version 6.12, which does support these cards. So Fangtooth is definitely the way to go here. So here we see the output from LSPCI from before an upgrade, and although we can see the video card here, there are some things missing. After performing the upgrade, we can now see the i915 kernel driver is running, and we'll be able to use those 24 GPU execution units on the onboard UHD 730. Fangtooth is also stable release as of release of this video, so there's every reason to use that with this hardware. Having navigated that rabbit hole, let's now get back to getting Jellyfin installed and getting that transcoding running. Now, there are two ways to install Jellyfin on TrueNAS. Either you can do it as a native application or as a custom container. However, both basically deliver the same functionality. It's just that the native app is a bit simpler as it automates some of the setup. So this is what we're going to do. If we click on apps on the left menu, we get to this screen. We then click Discover Apps and we enter Jellyfin in the search bar. Now, Jellyfin is an open source fork from Emby, and it's not only very capable, but importantly, it's free. And the options for free media servers is growing thin, with Plex now charging a subscription for many things I wouldn't count as value-added services. For example, reading your own media from your own NAS, transcoding it with your own CPU, and sending it to your own device for playing is now a subscription feature. This is not great. And I think Jellyfin is going to take significant share from Plex, and it's what I'm installing here. So next we select Setup Pool to install, and this tells TrueNAS which storage you will be storing application data on, and in this case it's the 6-disk array that I set up earlier. We will then be presented with a configuration screen with lots of options. So let's have a quick look at these and see what we actually need to do. So I'm going to set my time zone and set the fully qualified name of my TrueNAS server here with the TCP port of 8096. Now you can just put your IP address of your NAS here, followed by colon and the port number, and this is where the Jellyfin interface will listen. The user and group configuration should be pre-populated, and we'll use the user and group ID of site 568, which is the group used for applications. This is the account that Jellyfin will run as on the NAS. I'm going to accept the default port of 30,013 as the external web UI port for access to the app. Now, the Jellyfin app will create some persistent storage for its own configuration and cache, as well as for transcode storage, and this means that data isn't lost if the container is redeployed, and this storage is mapped to storage in the container for it to use. Now, this is an advantage of using the native app, is it basically does all this config for you and saves you all the mapping storage to the container, so you don't have to do it yourself. We will also click on this box at the bottom, which enables Jellyfin to directly access the GPU on the M150 CPU for decoding and transcoding purposes. Again, if configuring the container manually, you're going to need to map the right folder on the host so that Jellyfin can access this device. So one mapping you will need to do manually is granting Jellyfin access to the dataset that contains your media. Now, the mount path here is the directory as it will appear inside the Jellyfin container. So I'm going to set this to /movies. Then we provide the host path, and this is actually the location on TrueNAS that has the file. So in this case, it's /mnt/pool1/media. And there's a little icon you can browse to the location if you want to also. You'll also need to ensure that Jellyfin user has the right access to these files. So you can select the Enable ACL option and click the force flag, and that should adjust the access to the existing files in that directory structure. Let's deploy this and start the container. And the first time you do this, it's going to take a while because Jellyfin container has to be downloaded from the public repo. And then we see it actually deploying, meaning the container is configured and started, and then there it's running. Okay, look, we're now in the home stretch. Let's look at getting Jellyfin configured and getting that transcoding set up and tested. In the app section, select the Jellyfin app and click on the web UI link here to open the Jellyfin app itself in the browser. Initial configuration involves just setting up a user account in Jellyfin. For example, I've used Media User here. Configure the library location and select the movies folder we created previously. It's going to take a bit of time for it to discover the library contents, so let's get to the transcoding configuration. Now there are a lot of options here, but randomly clicking things or enabling everything isn't going to work. The GPU on the N150 has some specific support, and if you enable things that it can't do, Jellyfin is going to try and it's going to fail to use certain codecs and it's just going to throw errors. So we need to first configure the hardware device here, and this CPU supports Intel QuickSync for acceleration and uses the device you see here, which is also usefully directly used as an example in the text below. You can actually open a shell on the app container and browse to this location if you want to check the path. So here I configured decoding for H.264 and HEVC or high efficiency video coding and AV1 as our hardware supports these. I also turn on hardware encoding and enable the low power options for H.264 and HEVC. CPU does not support native AV1 encoding however, so selecting this will result in errors when encoding starts. You will need at least a Meteor Lake GPU for this. This is one of the ones with the Iris Xe devices, so stick with HEVC for encoding on this hardware. Save these settings and you should be good to go, but let's put this to the test. And here I actually created a rather demanding scenario for listening from Nutbox to see what it can really do. So first of all, I've started a scrub of the ZFS file system. Secondly, I have a copy running to write several terabytes of data onto the share, and then on top of this, I'm going to do a 4K transcode at the same time. And we can see here that the CPU utilization on the 4 cores, and we can also run a command in the shell called Intel GPU Top. Now this command shows the utilization on the GPU, and you can see here that it's dev dry card 0 device. And this also shows you that the transcode is being offloaded onto hardware. And as we start to see the transcode, we're going to see it ramping up. I'm not going to show the actual video content directly here, but we can see that the transcode is smooth and that it's being transcoded from 4K down to 1582 by 740, from HEVC down to 264 at 60 frames per second without loss and with a bit rate of about 80 megabits per second. Now, although load on the CPU is higher, it's not maxed out, and the CPU is doing many things at the same time here, including that ZFS scrub. Power at the wall is around 60 watts with all this going on, whereas the baseline was about 45 watts. So, having got all this running, let me share some of the learnings here, as there are definitely some. But first, if you enjoyed the content, please do hit that like. If you want more content on NAS and storage, please also consider a sub, and leave your comments below if you have any observations on this and how you feel generally about the mini PC approach compared to, say, secondhand servers or using spare components. And also feel free to go and rant or otherwise on USB storage on TrueNAS. And to the learnings. First of all, USB is frowned upon with TrueNAS, and I did actually initially have problems with the ZFS file system falling over. If I looked at the logs, I was seeing a lot of USB timeouts, and this was degrading the array, and this is probably why USB is frowned upon. But I tested this with Unraid also, and I found similar problems with USB timeouts causing the array to fail there. Unraid, I think, is generally more accommodating on this, so this definitely suggested to me that there was an actual problem. I even did firmware upgrades on the AS Media USB Silicon in the DAS devices because this doesn't seem to be a common problem, and plenty do use USB storage, but this didn't help. It was a bit of an adventure, however. But in the end, it actually just turned out that it was just a bad USB-A to USB-C cable, and after a lot of fudging around, I used an anchor cable and the problem was resolved. Testing the cables for capability says that they're both good for USB 3.2, and they both did show 10 gigabits per second negotiated in LS-USB, but my tester really just validates connectivity and it doesn't do full test of the throughput. I'll also link the anchor cable I used, as I've always found their USB and Thunderbolt cables to be excellent. If you do have issues, look in the log file for messages like this that you can see here, and this might tell you if there are USB issues that you need to deal with. After this, it's been flawless with 0 errors, and I've copied around 14 terabytes of data onto the NAS, and I've run more than 15 full ZFS scrubs without any problems. It's been running now for weeks, but I will report back later when it's been running for a longer time. I'm sure I'm going to create more TrueNAS content, so let's see how it works out for me. So good luck with getting your own TrueNAS and Jellyfin setup going. Have a great week, of course. Thank you for watching to the end, and I will see you in the next.